Um, so today we are talking about independent and dependent variables in the scientific process. So this is a concept that I have found confusing myself, and I've noticed that students are frequently confused by this, which is why I wanted to talk about it. So let's see what we can uncover about independent and dependent variables in science. So this is a picture of an experiment that someone was doing, and they called it the plant fertilizer experiment. And we see that we have group A off to the left and group B to the right. And in between, it says sun, water, location, and temperature with arrows pointing to both. So, and then over top of group B, it has just the arrow pointing to group B that says plus 10 milliliters of fertilizer. So, what do we think the experimenter is studying? Tylisha, I'm going to, do you want to
Could you
answer?
explain? No. Could you explain that again to me? I never seen that before.
Okay, cool. So, what I think the experimenter is studying is the effect that adding fertilizer to plants will have on their growth. So, the experimenter is keeping everything the same. So, notice that the plants look exactly the same from group A to group B. And this
Okay.
is telling me that they're both groups are going to get the same amount of sun, the same amount of water. They are in the same place, and their temperature is kept the same. So the experimenter is keeping everything the same except adding 10 milliliters of fertilizer to group B. Then I imagine that the experimenter is going to leave the plants, just add water, make sure the temperature is the same, not move the plants, make sure they're getting the same amount of sun, and check back on a regular basis, maybe once a day, once a week, once a month, and see is there a difference in the growth in the size of group B compared to group A. And we can imagine that if we're adding fertilizer to group B, we're going to expect that group B will be larger. So the hypothesis or the question that the experimenter is asking is, will the addition of fertilizer to plants increase their growth? Or what effect will fertilizer have on the growth of plants? And he is keeping everything the same except this fertilizer. Okay?
Okay, when you say keeping everything the same except the fertilizer. Okay, so they're testing to see if the fertilizer makes a difference in the plants.
Yes.
Okay. Okay, I think it does because group B does look a little bigger than group A.
Well, we haven't measured it yet. So this is
Okay.
okay. So, but that's what you would be looking at is you would be measuring the height and possibly the width, the diameter, to see whether there is growth there. So let's look at that. We answered what is the hypothesis. So that's the question. does the addition of fertilizer have an impact on the growth of the plants? Now, here's the critical point. What is the dependent variable? The factor that the experimenter will measure.
Is it group B?
The experimenter is going to measure both of the plants.
They're going to measure what?
They will measure both groups of plants. But what? What are they measuring about the plant?
The is it the fertilizer or the amount that it grows?
Which which one?
Is it the fertilizer or the amount that it grows?
Right. Which one do you think I'm asking you to pick? One of those.
Um, I think it's the amount that it grows.
You are correct.
Yay!
Yes. And I think the thing that's a little bit confusing to me is we have to be careful when we describe these things, because yes, he is measuring, the experimenter is measuring the fertilizer because he wants to make sure it's the exact same amount. But what the experimenter is looking for, the factor that the experimenter is trying to see if it has changed, is how big the plant grew.
Okay, say that one more time.
What the experimenter is looking for is how big did the plants grow? Because remember, we
Right,
said that
exactly.
is,
That's the dependent variable, right?
yes, yes.
Okay.
And then the independent variable, the factor that the experimenter is changing on purpose, is what? What did he change? What did the experimenter change between the two groups? What's the difference between group A and group B?
The amount of fertilizer.
Yeah, just even the fact that he added any fertilizer is the difference. And that is the independent variable. So when an experimenter is trying to answer a question, the plan is to change only one thing and keep everything else the same as much as possible. Just change one thing. So if in group B, we had changed all these things, we had given the plant more sun or less water, or put it at a different location, or change the temperature, we couldn't see for sure that any difference in size was due only to the fertilizer. It might have been any combination of things. So we try to keep everything exactly the same except for one thing that we're changing. And that is what we call the independent variable. And I think the reason this is confusing is, to me, is that independent. You have to look at it in one thing. Can you think of it as independent, as being on your own? So that's the one thing that is different. Or do you think of it as the dependent variable depends on the independent variable, because we're trying to see, if I change this one independent thing over here, what happens to the dependent variable? Any change in the dependent variable is because of what we did with the independent variable. So there are, I have lots of ways of explaining this. So we're going to go on, and what you're going to pay attention to is which definition makes sense to you. Okay. So Talisha, the one that you listen to and you go, oh, that makes sense. That's the one that we want you to focus on. All these definitions are different ways of saying the same thing. And I think it's the one that makes sense to you that you need to remember. Okay. And probably you will remember because it is the one that makes sense. There's one more question here that frequently comes up, and that is what variables are being controlled. And by that, we mean what variables are being kept the same. And in this case, it's all these things in the middle: the sun, the water, the location, the temperature. These are all things that we know affect the height or the growth of a plant. So we're going to keep them all the same so that only this one thing has changed, the fertilizer. So the things that we often talk about it as, we are going to control for these factors, meaning we're going to keep all this the same. Okay, so those are the control variables, or we say we're going to control for these variables. So in this plant fertilizer experiment, the hypothesis is, will the addition of fertilizer make a difference in the growth of the plants? The dependent variable is what we are measuring. That's what we're looking for. Did the growth of the plant change because we put fertilizer on them? So the independent variable is the addition of fertilizer. So the
Right,
hypothesis,
because that's the only thing that we're testing is the fertilizer, so it's independent because it's by itself.
that's right. That's right. That is the one thing that we're changing. And then the variables that we are controlling for, the ones that we are not changing, are the sun, the water, the temperature, the location.
Right.
All the same, because we don't want those to have an impact on our study. Okay. So here's another definition of independent variables and factors and so on. So it says, in a controlled experiment, the scientist varies one factor, the independent variable, and determines how this affects another factor, the dependent variable. Other factors or conditions that may also impact the outcome are kept the same. These are the controls. So if that helps you to think about the scientist of the experimenter varying or changing one factor, then that's the independent variable, the one that you change on purpose, and then you determine how this affects another factor, and that's the dependent variable. It's just another way of explaining the difference between an independent variable and a dependent variable. Here's another definition. Independent variables are the conditions that are determined, or is the condition that is determined and set by the experimenters. And the dependent variables are the factor or the result that is observed, measured, and recorded. So if we think
Right,
about,
right, okay, because the dependent variable with the plants would be the amount of fertilizer, right?
what do we observe, measure, and record?
The amount of no, to see if the plants to see if there was a change in the plants in changing the amount of fertilizer in both groups.
Did we put fertilizer on both groups?
No, we only put fertilizer on group B.
All right. So did we measure something in both groups?
No,
At the end of the experiment, what were we looking for?
the change in the plant that has the fertilizer.
What kind of change?
The um the size.
The size. Okay, so remember that we measured the size of both groups of plants. The plant that got the fertilizer and the plants that did not get the fertilizer. And we're trying to see, did the growth depend on whether or not the plant got fertilizer? Let's say at the end of the experiment, group B was much bigger, much taller, much fuller than group A. What would we conclude?
We would have concluded the fertilizer. The the fertilizer and the other factors, the water. I don't know if that's right.
Okay, we would have concluded that the fertilizer made a difference. Remember, we kept the
Okay.
sun, water, the temperature, the location, all the same. So the
Okay.
only thing that was different was the fertilizer, and that was something that we, the experimenter, added. So the
Okay.
is the independent,
Right. The independent is the fertilizer.
right? And that
Okay.
we determined and set because we were the experimenters and we said, we want to know if this fertilizer makes a difference. Say at the end of the experiment, uh, plant, the plants in group A, the ones that didn't get the fertilizer, were much bigger and taller and fuller, had more flowers. What would we, um,
You breaking up. I can't hear you.
excuse me?
Hello? I
Yeah.
couldn't hear what you said. The phone was breaking up.
Oh, okay. So if group A was much bigger and taller and fuller at the end of the experiment, what would we have concluded? The
We
one,
would have we would have concluded that the fertilizer does not change group B or does not have any effect on the groups in the size.
yeah, or possibly there was something that was not good for the plants if the other ones grew more, right?
Okay.
Yeah. So
Okay.
what if they were the same size at the end of the experiment?
Then it had no effect.
Beautiful. No effect whatsoever. Yeah. Because they look the exact same, then why bother putting that fertilizer on them, right? So
Okay.
in this case, group A, we also say group A serves as our control because it did not get the special treat that group B got. So if everything was the same, if we had not, what we want to know is happen if we did not give the fertilizer. So if, group B grew really beautifully and we said, oh, it must be the fertilizer. Well, how would we know if we didn't have some that didn't get the fertilizer so we could see the difference?
Right.
Okay, so that's the control group.
Okay.
Okay, let's look at another definition. This one is long, but I think it helps. Variables are factors in an experiment that can be changed, measured, or controlled. Independent variables are the manipulated variables. This is a definition I see a lot. And manipulated means experimenter manipulates them. The experimenter decides what they will be.
Okay.
They are the factors that will be intentionally changed during the investigation to find out what effect they have on something else. And then this final sentence is critical. Usually, time is an independent variable because the investigator can always decide how long to look at something.
Okay.
And the
Okay.
reason I have that International Exposition Center is because when I moved to Cleveland and heard everyone talking about the IX Center, that helped me remember that the independent variable always goes on the x-axis. So when you're graphing your data, and we're gonna see some of these.
That makes sense. That makes sense because when you're plotting the points, you start with the x-axis, then the y-axis. You go over, then up, or down, or however.
Right. So you're going to graph your independent variable on the x so that you can see what kind of on the y. So
you can see what
kind of change there is on the y-axis.
Okay.
Okay. So this says dependent variables are the responding variables. These are the factors that are observed and measured to see if they are affected by the change made in the independent variable. So that's another way of thinking about it. The independent variables are manipulated. The dependent variables then respond to what change you made, what change the experimenter manipulated.
Okay.
So,
Okay.
yeah, and I think the truth is that, I just use the term the changes made by the experimenter. And that makes sense to me, but it can also be confusing because we're measuring the changes and the responding variables. It's not as simple as saying which variables change because they are both going to potentially. It is which one do I manipulate? And notice I don't say control. Which one do I have in my control? Because that word we've used to mean what are the things that are the same. So, we just have to pay attention and think about what it is that we're trying to do in this experiment, remembering that the independent variable is the one thing that the experimenter is going to manipulate or do something different with. And then we're going to see how does the dependent variable respond to the special condition that the experimenter put on subjects, whatever they are, whether they're plants or animals or people or engines, whatever they are.
Okay. So the independent variable is always like the original. Is it kind of like the original project, and then with the dependent variable, you would add whatever factors you want to see what's the change between the independent and the dependent variable.
I think I understood what you said. And I think maybe the first thing you talked about where nothing has changed, that would be the control.
Say that again.
Where nothing has changed or like the original, that would be the control position where you just like, what is it if the experimenter isn't even there? What if the experimenter doesn't do a thing? That's the control. That's happens if I just put plants in my yard and I don't fertilize at all whatsoever. That's my control. Then experimenter, I come in and say, I'm going to add fertilizer to this group of plants and the thing that I hope will happen, the thing that I'm measuring is, will they grow more? Dependent variable. I think, yes, there's one more definition here. Independent variable is the factor the experimenter will test or change, and then the dependent variable is the factor the experimenter wants to measure. See if the independent variable made a difference. And I think that is, this very simple explanation is the one that makes the most sense to me. The independent variable is the factor the experimenter will test or change, and the dependent variable is the factor the experimenter wants to measure to see if the independent variable had an impact. So do you think any of those one of those makes more sense to you than the
I'm
others?
sorry. Could you say it one more time? I'm so sorry, Miss Ray. I'm so sorry.
That's not a problem. Do you think one of these explanations makes more sense to you?
Which one makes more sense to me?
Yes. Of all the that we
Oh,
use.
okay. Okay. I liked it. I think it was this one. Independent variables, the condition that is determined and set by the experiments. Dependent
Uh-huh.
variables, the factor or result that is observed, measured, or recorded. Control group, the condition lacking the independent variable, or the factors held the same in all conditions. Could you
Okay.
explain the difference? Could you explain the difference between the independent and the control?
Okay. Beautiful. In the independent or in the control, let's go back to our flowers. The group A was the control group. So it had everything that group B had. It had the same amount of sun, the same amount of water, the same location, the same temperature. The one thing it didn't have was this independent variable, the fertilizer.
Okay. Okay. So okay, I get it. Okay, so
Okay.
the independent variable is the fertilizer. It's the
Yep.
factor that's being tested
Yep.
on the that's being tested on the control group.
Absolutely.
Okay.
Let's look at a few more examples and we can figure out these independent
Okay.
and a couple of other things.
And I was just going to jump in and say, Tylisha, the only reason we need a control group is because we can't see what has changed by the variable unless we have something that we haven't changed. Like
Okay.
if I have a medicine that I'm trying out, right? And
Okay.
I give the medicine to one person and the person gets better. Did that person get better because their own body's immune system made them get better or because the medicine helped? And I don't know. So
Okay.
with when we're developing new medicines is we might give two people or we might find two people that are sick with the same illness and we provide one of them with the medication and one of them doesn't get the medication and we measure to see who gets better quicker or are there any side effects or things like that, and so we can see the change because we have that comparison between the two.
Right. Okay. Okay. So you tested the medicine with two people instead of
Right,
one. Okay.
right. So the person that does not get the medicine is the control, the person that's just sort of by themselves.
Right. Okay. Right. Okay.
And I'll let Julie get back to explain it. While Julie was flipping around, I thought that would be that's kind of a way that I try to keep it straight in there.
Yeah, that was helpful.
Cool. Good.
Yeah,
Okay.
great.
Here's
Yeah,
our next. Go ahead.
I've never really like been into science. So this is like my first time actually being interested in it. My science part of my GED, it was just so happened by the grace of God, I did not study at all, and I passed it. So I knew it was Jesus because I did not study. So it feels great to actually understand it.
Good. Good. Yes. That is amazing. You must have retained everything you thought, or
Yeah.
use your logic and common sense, because science, a lot of it is
Yeah.
it is logical. It's like math. It follows rules. And, if you can, a lot of the questions that I have seen on the science test, you don't have to be afraid of all the terminology, but because you can think your way through it. So good for you.
Right. Thank
You
you.
have a good understanding, a good sense of logic.
Thank you. Thanks.
Let's see if we can apply it here. So a
Okay.
student hypothesizes that eating a teaspoon of raw honey will prevent sneezing in people who are allergic to pollen. I have heard this as well. I mean, this is one of the theories is that you should eat honey from bees that are local to you, that will help. I don't know if that's been proven or not. But I have tried it myself. I try to eat only local honey. Anyway, experiment to test her hypothesis. So her hypothesis is eating a teaspoon of raw honey will prevent sneezing in people who are allergic to pollen. So let's think, what is it that she is changing? What is the experimenter changing?
The sneezing.
She hopes that she will notice a change in sneezing.
Hey, Miss Ray, could you give me like 10 minutes?
Yes, I can.
Thank you so much. Thank you.
Huh? For a
This
long.
conference will now be recorded.
Yay.
Oh, thank you for remembering to record, Chris. Okay. So the student, let's picture what her experiment is. She thinks that if you eat raw honey, you will prevent sneezing. Her experiment.
Okay, so it's not the sneezing then.
It is not this. Wait a
The
minute. What
dependent
the dependent variable?
the dependent variable.
I'm not sure what I asked you before.
It says a student hypothesis that eating a a student hypothesized that eating a teaspoon of raw honey will prevent sneezing in people who are allergic to pollen. She runs an experiment to test her hypothesis. What is the dependent variable? Ooh, pollen?
So what I asked you before, I did not ask you what is the dependent variable. I asked you what is it that the experimenter is changing is actually the independent variable. So what is she changing? So Tylisha, I want you to
Oh,
envision
she
that. Let's let
okay.
let's picture she's going to recruit a bunch of people. What should all the people have? What should they have in common?
The teaspoon of raw honey. No, no, they have allergic to pollen.
Beautiful. They are allergic to pollen. So she divides them into two groups because she wants to have a control to see if her experiment, if what she does makes a difference. So she divides this group of people into two. One group, her control group,
Are okay.
do they get anything?
No, the control group that has the allergic reaction that's allergic to pollen does not get a teaspoon of raw honey.
That's correct. And then her experimental group, what does she change? What does she do to this group of people? What does she manipulate? What does
The She gives them the honey, the
she
raw
gives them
honey.
honey? So that's the thing that is the one thing that she manipulates, she does differently to that group, is give them raw honey. So that's the independent variable.
The raw honey is the independent variable.
And then, I didn't hear that.
The raw honey is the independent variable.
Beautiful. So what does she measure for all of the people?
She measures their sneezing, their amount of sneezing, or she
Beautiful.
measures
So what is the
the dependent variable is the amount of times the dependent variable is the amount of times the group that got tested with the honey, the amount of sneezing they had compared to the amount of sneezing the control group had.
beautiful? That was such a great answer. I thought you were going to stop at the before you said compared to. I was like, you said compared to. I was like, yes, that's perfect. So it's the sneezing, the amount of sneezing that she is evaluating. So if the people who got honey, what she's hoping is the people who got honey will sneeze more or less than the other people.
Right. My brush right
Which
now.
one? Was she hoping they would sneeze more or less than the control group?
She was hoping they would seize less.
Perfect. Right, because her hypothesis is that honey will prevent sneezing. So she's looking to see whether the people sneeze less. She has to measure both groups, because if they sneeze the same amount, then her hypothesis did not work out, and honey did not make a difference in the people.
Right.
Beautiful. Let's look at another one.
Praise the Lord.
What did you say?
I said praise the Lord.
You know what? I don't even want, this one is too long and we just have a little bit of time left. Let me go to the next one. You want to find out how the size of a sugar cube affects the rate at which it dissolves.
How the size of a sugar cube affects the rate. Oh, okay, the rate, like time, like how fast does the sugar cube dissolve?
Yes, exactly. You
Okay.
use sugar cubes of different sizes and record the time until no solid sugar is observed in the water. You use the same volume of water at the same temperature for each cube. So,
Okay, but the sizes. Okay. Who is it?
so what is the independent variable?
The independent variable is the water. Is the independent variable is the independent variable the water?
It is not.
No.
Look what it says here. You use the same volume of water at the same temperature for each cube. So if you're keeping it the same, that's not the independent variable. What is the thing that you are manipulating? What is it that the one thing that you are?
Oh, the amount of water.
Nope, same volume.
Oh, volume. Right. So so the independent variable is the volume.
Nope.
No.
Nope. Let's go back to the question. You want to find out how the size of a sugar cube affects the rate at which it dissolves. Here's the clue. You want to find out how the size of a sugar cube affects the rate. You're looking for how does something affect something else, and then here's another clue. You use sugar cubes of different sizes. Select the scientist and changing it. And then you are recording, observing, and recording time. And you said, let me see if I can find which one that is. Maybe that more. What is the experiment determining and setting? What factor are you observing, measuring, and recording? Dependent variable.
The rate.
So beautiful. The rate, you know, that is the rate is the dependent variable. What do you choose to manipulate in this experiment? Are you there, Tylisha?
Hello.
Hi.
Yes, I'm here. I'm sorry.
Okay.
I had to put my phone to the charger.
Okay. So
The end of
measuring, we're observing the rate which it dissolves. What is it that we changed in this situation?
we are changed. The time, the rate.
Nope. That is what that is what depended on something that we controlled. As the experimenters, what did we choose to do?
What does what to
What did the experimenter choose to do? We used sugar cubes of different sizes. So that's the piece that we
different sizes. Use.
Yep. So the independent variable is the size of the sugar cube.
Oh, okay, right, because the water will the water dissolves the sugar cubes. So they're measuring the rate of they're measuring they're measuring to see how much water will dissolve one of the each sugar cube the fastest. So they're the so there have to be a group that is they both have to be the same size.
I'm drawing a little picture here.
Okay.
Okay. Let me stop sharing. So here's my picture. So let's say that these containers are all the same size. Let's say it's a 1 cup measure, 1 cup of water at 60 degrees. I have containers, 1 cup container, 1 cup of water, 60 degrees in this one. I have 1 cup container, 1 cup of water, 60 degrees. So what is the different thing in this picture?
What is different?
Yeah, I put a little sugar cube in here, a medium-sized sugar cube in here, and a big sugar cube in here.
Okay, but they all have the same amount of water.
They all have the same amount of water at the same temperature in the same kind of container. And to use a stopwatch, and I'm going to measure at 1 minute, 2 minutes, 3 minutes, 4 minutes, until I can't see any sugar left in each of them. So my thought is that the smallest one will dissolve first. I've never done this, but that's I think this one will dissolve next, and I think this one will dissolve last, that there will be most sugar left for the longest time. So let's it takes 5 minutes, 7 minutes, 9 minutes to dissolve. I have no idea. If you don't put it in coffee and like the variable is, in this case, is time. I measure what effect we have the rate at which that rate is measured in minutes. So the size of the cube is the independent variable. The rate depends
The phone is breaking up.
I hear that. And it is 11 o'clock.
1 second. Okay.
So we're going.
It's breaking up.
Yeah. We're going to end.
Thank you so much.
You're so welcome.